In this video, we're going to learn about, and we're going to cover chapter 3, which is linear and exponential change. There are 3 sections in this chapter that we're going to be covering. We're going to start with section 3.1, which is about lines and linear growth. I'm going to show you a picture of a graph. We've all have seen something similar to this before. This specific graph right here shows, let's see, the monthly ice extent declining from 1979 to 2014. So this is the ice extent right here. And this is the monthly, or we could say right here, yearly, from 1979 to 2014. Now, why did I say 1979? Because if you look at right here, it didn't start from 1978. It started like one step further. So this kind of graph, if we would say, we've all have seen something similar to it. But have you ever thought of what is this line right here, the red line that they give us? This straight line helps us to understand the decline, like you see in this case, because the numbers are going downwards. So this line would explain it. How? Well, a straight line is a type of function. So this line, this straight line, represents a special type of function. That function is called a linear function. Linear function. Now, I think you can right away guess that, well, it says linear, so comes from the word line. See the word line? It's inside the word linear. So that's why it's called a linear function. Let's try an example. Let's try a different example. If we want to write a linear function, we want to know what kind of growth it has, or whether it's growth or otherwise. Let's start with a simple example. By the way, this graph is on page 139 of your textbook if you want to read more about it. Okay, I want to start with a simple example. If I say, this example will help us understand linear functions more. I want to start with $100 in a cookie jar. If I have $100 in a cookie jar, and each month I want to add $25 to it. Okay, we can think that the number of months as independent variable and the amount of money in the jar as the dependent variable. Now, why is this doing this? You have seen, sorry. Okay, this was giving me a little hard time, but okay, it worked now. So we all have, if you want to look at why dependent and independent, okay, I want to say I start with $100, and each month I'm adding $25. So let's say I started in January. January, I had 100 and I added 25. So now I have 125. February, I added another 25. So now I have 125 plus 25. And I keep on going. When I said month is independent and money is dependent, why is that? Well, if I were to draw the graph, and you know when we said independent and dependent, we know that independent means X, dependent means Y. So on the Y-axis, we put it here, and the X-axis, we put it here. But you would say, why did you choose months as independent and the money as dependent? Well, let me ask you this. Which one you do have control of and which one you don't? Anytime I want to know which one I should write right here and which one I should write right here, I would ask myself, okay, which one do I have control of? Do I have control of the months, or do I have control of the amount of money that I put in? Well, think about it this way. Whether you put money in the jar or you don't, if it was January, it's going to keep going. It's going to become February. It's going to become March, right? So you don't have control over time. And that's why if you noticed in all the graphs you've seen, you will always see over here as your independent variable. And in this case, it will be the months. So I'll put the months here. And the money, or the amount of money I have, going on the y-axis. So anytime, let's say I ask you, write me which one is independent and which one is dependent, ask yourself, which one do I have control of? The one you do, you put it as dependent. The one you don't, you put it as independent. Just like over here, let me go back to this graph. Do you have control over the number of years? No, the years will keep going. And you will notice that time, most of the time, if you're comparing time to something else, that would be put under the independent. Okay, so we started at 100. When we first started, we started at 100. Let me break that down a little bit. Let me put right here $100. And then the first month, we said January, we added $25. This is January. Okay, January was $25. February, let me put month 2, added another $25. Month 3, another 25, another 25, another 25. So if I keep going and I look at it, it's going to be a straight line. And that straight line is a linear function. Okay, so we have a function of number of months. Why? Because we know the function is always of x. You see when we write f of x. So it's the function of whatever I have in the x values, which are here, the months. The function of the number of months since we began saving. And so looking at it in this case, what do we see? What do we see right here? We see growth, that it is going up, right? So we have right here what is called the growth rate. It's constant because every single time, how much are we going up? We're going up 25. We're going up 25. We're going up 25. So that is a constant growth right? And later on, you'll see it's a constant rate of change. Like we're gonna same change every time we go. It's gonna be the same thing. Every month, we are changing it by $25. So this function has a constant growth rate. With what is that called? It's a linear function. So what is our key concept right now? Let's see if I can change the color. So our key concept right here, a function is called linear if and only if it has a constant growth rate. Okay? Okay, so now that we know what a linear function is, I want to add another graph. This is on page 140 of your textbook. Now look at it. A graph can have the growth, the constant rate, constant growth can be either a negative number or a positive number. Right here, it was a positive number, which was 25 because it was growing by 25. Let's look at right here. First of all, you see that we have a straight line that shows this is a linear function. Same thing goes for this one. Now, this one's going up, so we would say growth. This one is going down, so we would say this is a decreasing function. Okay. An example of a decreasing function. Can you come up with an example of a decreasing function other than the one that was right here that we show? Let's go back to the cookie jar. Well, in the cookie jar, we started off with $100, and every month, well, actually it's right here, taking money away from the cookie jar. Every month I take away $5 or whatever it is. Every month I take out $5. This is a decreasing function. Adding money to the cookie jar is an increasing function. Now, what if there's other kind of functions? Let me put one more graph. Is this a linear function? Well, no, it's not. Why? Because it's not a straight line. Now look at it. How come? It's age and height. Now, don't just depend on it, on making your decision based on if you see a straight line, because some people might draw it like this and put like 2 down here and like change their scale. That they might think it's a linear function, but let's think about it. Age is your independent because it's down here, and your height is your dependent. Now think about it. Which one do you might have control of than the other? Do you have control of your age? No, because no matter what, time is going to keep on passing and you're going to keep on growing. But your height, on the other hand, you might not become tall. You might become very tall, but you might not be tall. So you have control to some extent about your height more than your age. So age will be your independent variable. Now we look at it. Is it standard that everybody at age 5 would be, I want to say if this is, what is this? 25. So everybody would be about 30 inches. By age 10, look at it. Like not everybody, you're not growing steady. Like you're not growing every year 2 inches or 3 inches. Some people might not. So that's why it's not a linear growth. Okay. So I'm going to keep a couple examples to solve in class. And then I want to give you now the other examples we're going to solve in class. And I'm going to move on to giving you the formulas for linear functions. Okay, so let's go back to the cookie jar. We said formulas for linear functions. Okay. We said, who was our independent variable? Months. So at month 1, we had $100 plus 25, right? By month 2, we had $100 plus the 25 plus another 25. By month 3, we do the same thing, 100 plus 25 plus 25 plus 25. Now I can go ahead and keep on going, but let's look at the pattern right here. I can change this to put it 2 times 25, right here, 3 times 25. And what is this 2 right here? This 2 is this 2 right here. Now right here, I can put an imaginary one. This 3 would be this 3. So can you guess at month 100? No, let's not use 100. Month 75, what would my formula be? My number would be, well, it would be 100 plus 75 times 25. Can you can, like, when I ask a question, you can pause the video and try it out. So now, when we said, let's assume x equals n. So if x equals n, then what would we have? 100 plus n times 25. So what do you see right here? We see a pattern. So if we say y, or which is your function of x, because again, in terms of the months, equals, we always start with this side first. We write 25n, or instead of n, we'll put x because n equals x plus 100. And that is the linear function that you guys have seen. Y equals 25x plus 100. If I am to read it, let me rewrite it as f of x. If I am to read it, I'll say, what's my baseline, which was $100 I started with. And every month, I start out with $25 per month. So if they're beside each other, that is like per month. Okay. And from this, we can write it as, let me see, 100 is my initial value. 25 is my what? My growth rate, which is, in this case, it's positive. So I have, it's going up. Yeah, that's what it is. And we all should be familiar with this, and it's known to be the y equals mx plus b format, because it's growth rate and initial value. B is denoted for the initial value, and m is denoted as the growth rate, which is often known as to be the slope. Now, we learned it back in high school that it's the slope, but the more general form, it's the growth rate. So you will hear me say growth rate or slope. Okay, so if we were to graph it, we will say like that. The growth rate y, I'll do something like this. This is 1 unit. And this is the slope, and we'll find a few ways later on to know how to draw or find the slope. And this is y equals mx plus b. It's the equation of a linear line. That's why we've known that y equals mx plus b is a linear line. We'll solve more problems in lecture in the class. Let's see. Finding and interpreting the slope. The next section. Okay, we are gonna say in this section, we will say finding and interpreting the slope. We're gonna know finding and interpreting the slope. So again, what did we say the slope is? Slope is growth rate, which is the change in function value, because remember, it's the change in function value over the change in the independent value. So you see why I drew here? Because it's changing, going up. So you start from here. That's my y value. And this is my other y value. So there is a change in the y value. As for the change in the x value, there's right here. This is my x1. This is my first value of the y. And right here is my x2 and my value of y2. If that sounds familiar, you are on the right track. So we say it is the change in y over the change in x. So whatever the y is, or in whatever the x is, remember, we had high, like $125, remember, in the, I don't want to go back that way, but we had $125 in the cookie jar in January. So let's call it month 1. And we had $150 in month 2. So what is the growth rate? If I were to find the growth rate or the slope, I would say, okay, what's my change in y? My change in y is 150 minus 125 over the change in x, month 2 minus month 1, which is 25 over 1, which is what we had originally, $25. And that's how we would solve it, and using different examples. The other part, now I'm only using this one right now in these notes. The other one would be the one we were drawing $5 every month. And that would be one of your questions that you have to submit to prove that you guys listened to this lecture. Your first question would be, write me the equation of write me the function with the growth rate of removing $5 from the cookie jar if we start each month, if we started out with $100. So hint, hint, you start with y equals mx plus b. What's my slope here? I'm removing, what did we say a decrease would be? Of $5, and my initial value would be $100. So that would be the first question you guys have to write on the test, on the quiz on, when is it, Tuesday? Yep. Okay. We'll solve more problems about that in the book, in class. So question 1 that you need to submit, write the function value, a function of removing $5 from the cookie jar that has $100, that has $100 to start with. Okay. Okay. Sorry, I lost connection for a second there. But okay, the next and final section that we will be covering would be about the regression line or trend line. Regression line or trend line. Now in this section, I'm just going to go over it very quickly right now. I'm going to be covering it during class. I want you to be able to have a TI calculator with you, and because we will be able to solve the following problems on the calculator. Now, some people might learn to solve it on Excel or other places, but I usually use the calculator for it. So make sure during class you have your calculator, because we're gonna walk through it. This would be an example of what we will be doing. And let me put both pictures. Okay, so how to draw a regression or trend line. If we are given a the running speed and length of how many animals? 6 animals, their length and their speed. We are told to draw the trend line and to see how close is the average. Now, if you know the linear one, the linear function that we drew, it was that all the points were straight. The trend line is it's the line that comes very close to all the points. So if we look at right here, the length and the speed. Now, the first question I want to ask you before you look at the graph, if you would see, you would think, what is, hopefully nobody saw it yet, what is who's the independent and who's the dependent? Well, let's look at it. Is it the length or the speed? If you thought length, you're right. Why? Because do you have control? Let's ask yourself, do you have control of the length or do you have control of your speed? Well, you can be going so slow. Today, I don't want to run. I want to walk. So you control your speed, but you can't control your length in this case. So that's why the length is the X value and the speed is the Y value. So we take all these points, let me do this part. We take all these points and plug them in. Okay, and then we put the speed, you know, we find each point and we put it, but then drawing the trend line. And again, that line, you have to draw a line that fits as close as possible to many of the points. Now, we used to draw it by hand, but now with all the calculators and stuff, we draw it and the calculator would give us this line, the closest linear line to come to all the points. So which is like the distance. This is, if we were to add those distance from each point to the line, it is the smallest ones you can have. Because some people say, oh, why can't I draw it like this? Why can't I draw it like this? Well, then the distance of every point will be more. The shortest trend line is the closest one, which is in this case, it's this guy right here. And I will show you on the calculator how to find it. So the equation of a trend line would be, look at it, y equals mx plus b, where m is my slope, the rate of change. So at 2.0298, that's my rate of change for, and the initial value was 5.0873. See, it's not a nice number. So just to finalize it, given a set of data points, that's the key concept, given a set of data points, let me write it in a different color, regression line or trend line. You might hear people say regression line, you might hear people say trend line, is the line that comes as close as possible to fit those data. Okay, and that is a definition that you need to know. That's another hint for Monday's quiz, or I mean Tuesday's hand-in quiz assignment, whatever you want to call it. Okay, so this is it. Now you would be able to solve the homework assignment and be ready for Tuesday. On WebAssign, I did assign section 3.1, and I will update the due date for it. It will be due, let's see. If we start on Tuesday, it will be the first lecture. It will be due on the 6th. So the 31st, it will be due on the 6th. Assignment 1 will be due September 6th on WebAssign. Okay,